Namaskaram everyone. Welcome back to the 23rd episode of our Master Unreal series. And in this episode, we are going to implement the start state in our animation graph so that when you transit from idle to cycle, you have that weight shifting behavior to make it more realistic. So that's what we are going to implement in this episode. And we are going to do with the distance matching. So in this tutorial, I'm going to give you an in-depth guide of how the sequence player evaluator works, how the distance matching is going to solve your problem, how do you set the blend durations, how you synchronize the foot, how do you synchronize the pose between two different states, how do you apply inertialization while blending the sequences. We are going to discuss everything in detail in this episode. So without wasting any time, let's start. Okay, so we are in our editor now. So this is what we had last time, and now we are going to implement the start and stop. I'll try to implement both in this episode, but let's see how much we can make in 30 minutes. So before we begin anything, in the event graph of BP third person character, I want you to go and mark this running settings applied. So if you haven't watched the previous episodes of Locomotion series, please check it out. The playlist is appearing in the top right and it's also in the description. So make sure you check this out so that this function will allow to set the values of walking mode when the event begin play is fired. Okay, so now if you play, you will have the basic speed. Okay, so let's go to our animation blueprint. In the characters, mannequins, animations, you will find your ABP base. So this is what we did last time. Let's open the locomotion state machine and let's break these two links. I would like to go from idle to start. So I'll create a state, name it start. And let's rename this one to cycle since it includes both walk and run. Then we go here and from here we will go to stop. So I'll create another states and from stop we go back to idle. And also let's say you have just started the walking and that transition is not yet completed and you stop. You released your key. That means I have to stop. So I'll add this transition and this can happen here as well, that let's say you are walking and you released your key. Now the stop transition is happening and in middle of transition you again press the W or some other key, then you will start walking again. So this is why we will create these two bidirectional transitions between start and stop as well. And now let's go to the first transition rule, that is from idle to start. So this is only possible when you are accelerating or you have velocity. So for this, I'll go in the blueprint thread safe under velocity data. So in the update velocity data function, we will create a variable. Let's promote to a variable and we will call it local velocity. So this local velocity does not consider your rotation or basically in what direction you are exactly having the velocity. We nullify that part. So that's what it will store. So I'll use the unrotate vector. And from rotation, I'll get this character rotation and I will plug it here. So this will just give us the pure vector in single and same direction every time. Once we have this, we will check vector length xy squared. So since we are allowing movement in xy direction, that's why we did this. And we will check if it is nearly equal to 0. If that is the case, then I'll again create a variable and I'll call it has velocity. Now it doesn't matter in what direction. So that's the reason we created this local velocity. And we'll plug it here. A small correction, it should be not boolean because so if it is not equal to 0 or almost not equal to 0, that means it has a velocity. So now we know whether the character has velocity or not. So in the idle to start rule, we can say has velocity and is accelerating. So if any one of them is true, that means we have to transition to start. Is accelerating means you have pressed W key, and has velocity means you might have got velocity from some other sources as well. There is a possibility which I'm not going into right now, but these are the two things. And I'll just make a shared rule and I will call it start rule. So, just like you have variables to store and you can use them anywhere, this is one way to store this rule and use it anywhere. So if you go stop to start, that means you need to press the movement key or your character should get velocity in middle of the transition. So this is the same rule. So I can use this rule that I created here. So once this transition is over, we want to move to cycle automatically. So I'll mark this true. And if you want to go from cycle to stop, you have to release the key. So I'll just bring has velocity is accelerating, and let's move this has velocity in the velocity data and local velocity here as well. So if any of them is true, then we will just do the negation, not Boolean. So both the cases should be false, then only you can stop, right? That's why we use not. Now I will hit compile. I'll go back. And again, I want to use this for start to stop, because let's say your start transition is playing and in middle you release your key and your character is not getting any velocity, then you want to get back to stop. So we can use that same rule here as well. So I'll just select it, and first I'll create that. So let's go stop rule, and we can just reuse it here. Okay, and we go from stop to idle automatically once the stop transition is over. So I'll just mark this automatic rule based on sequence player. Okay, so we are done with the graph. Now we can go inside our locomotion, and in the ALI, we can create layers for handling start and stop. So I'll call locomotion start. I'll create another that is for locomotion stop, and I can ungroup them. Once you are done, just hit compile, go back, and in the start, you will find locomotion start available here. So let's just plug this, compile, and in the stop, I can plug the stop layer. So now these layers will be overridden by the locomotion layers base. So I'll go inside that, and here I'll find these two layers. So let's begin from the start. I'll close other tabs. First thing we would like to do is sequence evaluator. Now why we are using sequence evaluator and not sequence player? So the sequence player is used for playing the sequence continuously, right? Whatever your animation is, it plays it completely. Now you can pause it, resume it, or you can loop it. Like for example, in the locomotion cycle, we are using sequence player and we have set the loop animation to true. So it will keep playing this animation as the time goes, okay? You can also provide the start position, play rate and play rate basis. But when it comes to the sequence evaluator, it does not play animation over time. So let's say if I talk about this forward start, if I pause it, now let's say I gave him time 0.27, it will pick exact this frame and it will render. If I give it 0.74, this will pick this. That means it gives you a power or privilege to skip frames. So that's what we need, because in the distance matching, we want to know based on your character's speed and the distance it is traveling, we want to pick the correct frame. And for this, I would recommend you check out episode 10. That will make you understand how this seconds and picking up correct frame plays an important role in the animation. So since we are using distance matching, we want to pick the correct frame based on the distance we have traveled, and that is decided by the character's speed that you have set in the character movement component. So we want control over the animation. We want a specific pose based on the distance we have traveled and the position we are in, right? So that's the reason I'm using sequence evaluator and not the sequence player. Now once this is done, we will just connect it to this. This sequence is dynamic because this sequence evaluator will be able to pick any frame from any sequence we are going to provide. So this is a start. Now this start transition will be different based on each category. If you are unarmed, it will be different. If you are crushed, it will be different. If you are carrying a gun, it would be a different. That means our animation will be different every time, and that's the reason we are picking dynamic. And next is the explicit time. We will set it dynamic and we will not expose it. Again, we want to have a control over time. We want to pick frame based on the time we want. So that's the reason we are doing this dynamic. Okay, so this is done. As soon as you press W, the transition rule will transition you to start. And when it transitions to start, when it will arrive on that start state, we quickly want to check what is your stance. Are you standing or you are crouching? And based on that, we will pick the correct animation and we will start emitting the pose from that animation, right? So for this, we will use this on become relevant. So this will be fired as soon as you arrive on this state, and you will find this function added automatically. Let's rename it setup start animation. Since we know that this function is purely for that sequence evaluator node, we will assume that this is what we will get. So we will directly convert it to Sequence Evaluator using this pure function. Now you can see it is giving result because let's say if you make a mistake by plugging this function somewhere else, it will not be converted into a Sequence Evaluator and it will result false. But in our case, that will not be a situation because we are conscious enough that this function will be binded with the Sequence Evaluator. So I'll not check whether this parse is successful or not, and I'll directly set the sequence. And now there are two ways to set the sequence. One is you directly set it, and another way is you blend with the previous pose. So if I go for pure set sequence, it will play the new animations pose immediately. It will not even blend in with my previous pose, and that will give you a more of a snappy feel. So we don't want that. We want it to blend in with the previous pose that we were playing. Let's say I was walking and then I immediately started running. Then in that case, I want to see that smooth transition. I do not want to immediately play that first pose of running. So for this, I will use this set sequence with inertial blending, and I'll provide this context here. And then we would like to set the explicit time. So this node will allow you to pick the frame from the animation based on the time you will provide here. So this is the 0, 0, and this is the frame that will be played first. As soon as I go further, I can pick this frame as a starting frame when the transition happens. So the timing is 0.7. So if I provide 0.7, it will start from this pose, not from this pose. But we do not want that. We want to start it from 0 so that we can see this weight shifting. So we'll go back and we'll keep it 0.0. Now the sequence. So there are three situations. One is that you have the walk start cardinals, and the type would be Anim struct cardinal directions. This is the type we created last time. And then we will have jog start cardinals, and there is another one that is crutch start cardinals. So you can start walking in these three situations. Now let's go for a select. Then we will call a property access node, and we will choose whether we are crutching or not. So if I'm crutching, then I will pick this crutch start cardinal. I'll split it and I'll just plug the forward. In this episode, we are only focusing on the forward direction. In the next episode, we will implement all these four, but for now, we will just consider the forward animations. So if it is not crutching, then the character can be walking or running. So we will again go for a select. And here again, I want to go for property access, and I'll go for is running. I'll connect this to this. Now if he is running, then we want to use the jog start. Again, split it, pass the forward. And if it is not running, that means for sure he is walking. So we'll plug this. Okay, so these are the possible animation. The correct animation will be given by this select node, and then it will pick the first frame and it will play out. But now this was completely for the starting point when the first frame was supposed to be played. But like I said, evaluator only plays frames. So you have to continuously provide the next coming frames. So for this, we will use this onUpdate. So onUpdate is fired every time when the Unreal expects a pose from this particular node. So we will bind a function. So I'll go for create binding and I'll rename it to update start anim. Okay, so this will output the correct frame as time passes by. And here we have to pick the correct frame from what speed you are moving and how much distance you have covered. And based on that, we will pick the correct pose from the animation. So I'll go for advanced time by distance matching and I'll plug this here. And since we know this would be Sequence Evaluator, we can convert it to Sequence Evaluator using this pure function. Plug it here, plug it here. And how much distance has been traveled? We know we have created this already. So I'll go in property access, NMBP thread safe, and the displacement since last update. We'll pass it here. And now the distance curve name. So I'll create a variable that will store the name. Instead of hard coding it here, you can provide it in the variables so that you can reuse it in other places if you need. So I'll call it distance curve name, or let's call it location distance curve name, and it would be of type name. I'll plug it here. The sequence evaluator will be updated by this node, and the animation is already been set by the setup start animation. So the sequence evaluator already has the animation. You have provided the distance travel. You have provided the curve that is present in that animation. So let me tell you where it is. If you go to this walk forward start, you will see this distance curve. So this distance curve is present inside this animation and it will be picked up by that node. Okay, let's quickly understand this particular advanced time by distance matching. So the sequence evaluator and context we have already provided. So this is the displacement. So from last frame to this frame, when you moved, how much distance you covered, this is what you are going to input. So if I play and change the preview instance to ABP base in the ABP base blueprint, and now just observe here, this is the displacement speed. Now if I walk, you see the displacement speed is 400 and just above it you see the displacement since last update is changing to 10, almost 10. It is like between 0 to 10. If I slow down my speed, you can see it is like around 4, 5, 6, but if I run, it's about like almost 9 to 10. And now we are providing distance 10 every tick. But the curve has a value from 0 to 721. Does that mean it is going to pick only the first few frames because of the distance that we are getting every frame that is less than 10? It's just gonna pick these frames? No. Often people get confused that this distance traveled is the total distance traveled. No. This distance traveled is the distance that you have covered in the last frame to this frame. Now, as time passes by, you will provide this constantly. So this will get accumulated inside the sequence evaluator and it is going to use that plus the distance that you have covered in the last frame to this frame. Let's say you start running. In the first second, you will provide 10 distance. It will get added. Then it will pick this frame and it will emit. Now comes 2. So at this 2, you already have 10 meters covered. And now in this frame, let's say you covered 8 meters. So it's like 18 meters. So this will pick this 18 meter from here. Then in the third step, you completed 10 meters again. So now the accumulated distance is 18 plus 10, 28. So this will pick from here. And this is how as time passes by, you will cover the distance and we will pick the frame with the help of this curve by providing you the accumulated value along with the last displacement that you have traveled. Okay, so that is the reason we have also named this variable displacement since last update instead of naming distance last update. So this is how the advanced time by distance matching picks up the frame and give to the sequence evaluator and then it goes in the output window. Now how do we get this distance curve? If you do not have this distance curve, you can go to window, animation data modifier. Here you can pick this distance curve modifier, and before you do this, make sure force root log enable root motion is checked. And then you can click on this and you can rename it to something else because distance curve name is already taken. So I'll call it distance 1 and I'll right click and I'll apply. Once you do that, you can switch back to Unarmed. You will find your distance curve here. Okay. So you can see it is exactly same as the distance curve that was there. Right now, I'll just remove this because we already have it. So we will pick the frame from this. Now, if I go back, we have provided the distance curve and we have provided the distance travel. Okay, and now I can go back to my locomotion start and I have this. And there's one more thing that we want to add is the stride warping so that we can avoid the foot sliding issue. Now remember the stride warping we added last time was in the cycle and we want to add the same in the start as well. So that when it starts, the foot is placed and picked correctly. And here we will select this to graph and the locomotion speed would be the property access and we will use the main NMBP thread safe and the displacement speed that we calculated last time. So we will connect this here. Now we need to provide the bones. So let's quickly give that pelvis, IK foot root. So my character has 2 legs. So I'll add 2 legs here. IK foot right and the foot right would be the forward kinematic bone and this would be thigh right and just do the same for the left. So IK foot L, foot L and this would be thigh L. All right. And the minimum root motion speed, let's set it to 0 and let's hit compile. Okay, and now I can go to ABP Unarmed layers and I can provide the animations for this particular layer. I can go to animations, I can search for start and just select all and deselect the jump animations. Okay, just don't make this mistake. Right click, asset actions, edit selection in property metrics. Under the root motion, just make sure everything is checked. Okay, save and go back to Unarmed layers. And now you can start putting the animations. And now I can start forward right here, left here, forward start here, backward start here. Then we can go for jog right start, jog left start, forward start, backward start. Then we have crutch, go for right, left, forward, and the backward. Okay, we have all the animations. Let's hit compile. Under locomotion layer space, make sure the distance curve name is set to distance. This is exactly the same name that we saw here. Okay, otherwise it will not reference to the correct curve. Okay, so I had a blunder. Unfortunately, my recording was in pause mode and I couldn't record certain steps. So I'm just revisiting them and I'll explain here. So first, when you go from idle to start, we want the duration to be 0.15 and we want the blend profile to be fast feet. It will be available for you by default. Now let's understand this duration part. So this duration lies between 0 to 1. So the less it is, the faster transition would be. So if it is 0, then it would be like a real quick transition. It would be a little snappy behavior. But if you set it to like 0.75 or for that matter 1, it will take its own sweet time to blend in from this state to this state. So our start animation is already a like of a weight shifting. So we really want to start from this pose as soon as possible. So we really want to go fast from idle to start. But when it comes to start to cycle, we want to take maximum amount of time to blend from this state to this state. Okay, so we really want to begin the start animation as soon as you press the key, and we want the blend time to be less. As far as that blend profile is concerned, since you are having such short amount of duration for this blend, the feet might slide and we want to avoid that. So to avoid that is use this fast feet blend profile. This is specifically for the feet of the characters so that they are more faster and responsive for such a shorter duration. Okay. Now these are the two things that I wanted to convey. You go back in the locomotion state machine. I want you to change this maximum transitions per frame to 1. By default it is set to 3. So set it to 1. And the reason is sometimes state machines acts little bit weird and they skip transitions, and we do not want to skip the transitions. Now I encountered this issue when I was using this animation blueprint for an AI character or NPC. So when we will come to that episode, I will address this issue. But for now, I want you to just follow my words and keep it 1. Do you see that sliding happening when the start animation is almost over and the cycle is about to begin? There's a dragging happening. If I press shift and then I start running, it is perfect. First, I want you to go in your third person character and apply these locomotion settings. The walking speed is 400 max and the acceleration is 350. But the running, the max walk speed is 600 and the acceleration is 800. So when you are just walking, we really want to see that start transition so that it gives you a more realistic feel. But when it comes to running, we really want to catch up with our speed, because when you want to run, you do not want to have that transition for so long. And if we want that transition, we really want to start the running fast as soon as possible. So we have to keep this acceleration higher than this max walk speed. So in 1 second, it will achieve this maximum speed. But here there is a gap of 50 meters per second because we really want to have that realistic feel in the case of walking. But when it comes to running, let's keep that user experience because not everyone wants to have a realistic experience. So this is one change that I wanted to convey. So now you observe the drag feel, and to fix that, we will go in the locomotion cycle layer and we will open this one, and you can remove that branch node which was present here because we already know that this is going to be plugged in the sequence player. So you don't need to check, but if you keep it, that's not a problem. Now we need to adjust the play rate. So the cycle animations play rate should adjust itself based on the speed we are following, because we are having different speed for the walk and for the run. So to handle this, I'll use set play rate to match speed, and the speed that we want to match is the property axis, and we bind it with our displacement speed. This will take care of our first situation. The start animation is finished too early as compared to the cycle animation. So we want them to synchronize with each other. We want their footsteps to synchronize with each other, because you saw the upper body was fine. It was just the feet that was dragging. So to fix this issue, I want you to go in the animations and create a curve compression. So here you will find curve compression settings and name it uniform indexable curve compression and change it to uniform indexable. Before we go on to the synchronization, I wanted to use this curve compression setting. The reason is, so this curve compression setting distributes the keyframes evenly. They have even space between each consecutive frame. So this is like an enhancement for the distance target node that we had. So first, I want you to go and open the start, select all the animations, just skip the start and the start loop, right click, asset actions, edit selection in property matrix. Root motion is checked. Under the curve compression, I want you to remove this filter, select this file and press on this. Okay, now it changes this curve compression for all the animations. Just save it. That's our first thing. Now we need to synchronize the feet. So first I want you to open any animation window, press this window option in the toolbar and select this animation data modifiers. Remember, this will not appear if you do not open any animation. So I want you to open any animation you like and then select this. Here, add the sync marker animation modifier. Just keep it. Click outside, control space to bring the animations. And you have your start filter. Select all the start animations except these two and right click, and in the animation modifiers, you apply modifier. Once you do that, you will find the foot sync markers in the start animations. And now if you select walk forward start, you will observe this thing that at this particular frame, your left foot is on ground. On this one, right foot is on ground. In this one, your left foot is in ground. And now we will use these markers to synchronize the pose of the start animation and the forward run, walk animations. So for this, I want you to go again in the forward and select all the animation, remove this stop, pivot, deselect these. Okay, now you have all the forward animations. Right click, animations, add modifier, select the sync marker and apply. And if it asks you this, just go for yes, apply to all and yes. It is fine because we already applied the sync markers on start. We are just applying it again. So I think that's the reason it was giving that warning again, but it is absolutely fine. Now, once all this is done, you can save all. Now you have the markers in forward start and in the forward. Now we can sync them. How do we sync them is by going into the locomotion layers base, go to start and name this group called locomotion. And this is a leader and it has to sync. Now, since this particular state is a leader, it will always provide its marker. And now it's the job of the locomotion cycle to synchronize with those. Now, we do not want to put the markers of cycle because cycle wants to blend in with start, not the opposite. So for this, our cycle would be a follower and it will be syncing with the locomotion group because that's where the start is syncing its markers, and we will change it to sync group. Now once you have this, compile, save all, play and just try W and you can see it's no longer shifting. And now you can apply this sync markers in all the animations. One is the normal cardinal directions. So let's say walk backward, walk forward, and walk left, walk right. Select the backward start, forward start, left start, right start, and then you can select backward start. Make sure you do not select pivot or stop at this moment. Okay, so we have selected all the start and the cycle animations of walking, jogging, and the crutch. And now you can right click, browse to asset. Once you do that, you can right click, animation modifiers, add modifier, and you can apply sync markers for on all of them and press apply, press yes. And since we have already applied in some animations, it will ask this warning. So just press yes as many times it asks, and you can press apply to all and yes. Okay. Once you are done, they will be applied and you can save all of them. And we have already applied the uniform indexable curve compression setting on all the start animations. So you will be able to see this here. And now if you try you can always run, you can crouch, and you see the start animation is much smoother now. One mistake that I made in the last episode, I want to fix it real quick before I end this episode. In the animation locomotion layers base, you can clear your terminal and you can compile, and you will find this issue. The sequence player is set to looping, and we do not want, because this setup crutch idle to start idle or vice versa is not supposed to be a loop animation. So we just fix this, and rest of the stuff is completely all right. So just wanted to remove the loop animation. And now since we have taken care of markers, we can go to our cycle animation and we can set this play rate to dynamic, so that this play rate match to speed can work, because if you don't set it dynamic, then it will not work out. So now if you compile, if you play, the animation is much smoother. So that's it for this video. I hope you enjoyed it, and it's okay if you are getting no pause after you stop the motion. It's happening because we haven't implemented the stop layer in this episode, and along with that we are also going to implement the directions so that you can start and stop your motion in all 4 directions. I wanted this episode primarily focused on how the distance matching and sequence evaluator and the curves and all that works out. Now since we have that clarity, now we can implement everything fast. So in the next episode we will try to wrap this up. So stay tuned, like the video, share it with your friends, subscribe to the channel, join the Discord community, and if you have any difficulty or obstacle or doubt or question, the comment section is always open. And if you find some issue in your code, or if you find something not working, feel free to post it in the Discord channel and I'll assist you myself in the best way possible. So till then, take care. I'll see you in the next episode.